In this question, we're going to see how we can find the minimum sample size needed for a particular situation by using Excel. This question says, you are the operations manager for an airline and you're considering a higher fare level for passengers in aisle seats. How many randomly selected air passengers must you survey? Assume that you want to be 90% confident that the sample percentage is within 5.5 percentage points of the true population percentage. So basically what we're doing here is we're saying we might want to increase the fare for the aisle seats on an airplane, but we want to make sure that this is going to be received well by our passengers, so we're going to conduct a study. We want to have a certain level of confidence in the results from our study. If we only go sample 5 people, it's probably not going to be a very good result, and we're probably not going to be very confident in the results. By the same token, we don't want to go out and sample 1 million people because we don't have time or resources to do that. So what's the number of people that I really actually need to survey so that I can be 90% confident that I'm getting the results that I want? So to do that in Excel, we're going to have to use a formula, which is this one, which you can find in the textbook. Unfortunately, Excel does not have a built-in formula for this particular option. Other programs do, like StatCrunch or StatDisk, or if you buy an extension in Excel, there are some easier ways to do this. But we don't want to pay extra money, so we're going to have to just go ahead and do the formula straight away. That's okay. So the first thing we need to do is we need to find the z alpha over 2. So first we're going to find the alpha value. Remember, the alpha value is just 1 minus the confidence level as a decimal. So if we look back to our problem, we wanted to be 90% confident that we were getting a certain kind of results for this survey. So the alpha value is going to be 1 minus 0.90. In Excel, we always start every formula with an equal sign. So we're going to type equals 1 minus 0.90. Enter. So this is our alpha value. Now we need to take that alpha value and divide it by 2. So the alpha here you see is divided by 2 in the formula. So alpha divided by 2, we're really just going to start an equal sign and take that alpha from above, just click on it, and then divide it by 2 like that. There's our alpha over 2. To find the z value now associated with our alpha over 2, that's called the critical value. And to do that, we're going to use the norm INV function that we first learned in the preceding section. We're going to go to formulas at the top, and then to more functions, statistical, and then all the way down. And we're going to choose this norm INV right here. The probability we want is 1 minus the alpha over 2 level. So 1 minus, and then we're going to click on the value we had for alpha over 2. We're talking about z-scores right now, so the mean is going to be 0, and the standard deviation is going to be 1. So we click OK. So this value right here is the z alpha over 2, also called the critical value. That's going to be this part of our formula once we get it. The other things in the formula we need are p hat, q hat, and e squared. E is the margin of error. So sometimes you will be given those values and sometimes you will not. Let's go see if we were given those values in this particular problem. So here you notice they did not give us any information about what the p hat would be. Remember, p hat is the proportion from a sample. We don't have any sample information here, which means we don't have a p hat. So what we're going to do is, when no estimate of p hat is known, instead of a p hat and q hat being multiplied together, we're just going to enter a value of 0.25. The reason we enter 0.25 is because it gives us the most conservative estimate possible. So 0.25 is what we're going to have there. And then for the e, that's the margin of error. That was given to us. So 5.5 percentage points is what we wanted there. We're working in decimals here, so 5.5 percentage points would be 0.055 as a decimal. So let's go ahead and put that in. The e, which is the margin of error, is going to be 0.055. If you don't remember how to change a percentage to a decimal, remember it's just taking the percentage and dividing by 100 like that. So you can see you get the same value. So now let's go ahead and build our N. N means the minimum sample size. Sample size. We should say minimum sample size. Minimum sample size. Okay. Let's go ahead and put that right here. So we're going to build our own formula to calculate this. We're going to start with an equal sign. Now the first thing we need is the z alpha over 2 squared. So the z alpha over 2 is this one. That's the critical value. So we're going to click on that. And then to square it, we're going to click the arrow key, which is Shift 6 on your keyboard, and then a 2 to make sure that it's squared. Remember, we're using this formula down here, so we're going to multiply that by 0.25, so times 0.25, and then we're going to divide all of that by the margin of error squared. So divide all of that by the margin of error, which was this guy right here, squared. So again, the little caret, Shift 6, and squared. And then we hit enter. So the minimum sample size here we got was a decimal, 223.5986. Remember, this is supposed to be the minimum number of people we would have to sample in order to get a good enough result for our purposes. We cannot have a fractional value of people, so we're always going to take this value we get here and round it up to the next whole number. In this case, we're not following the normal rounding rules where you look the digit after the number you're looking to round to. You look to see, is it 0 to 4, in which case you round down, or is it 5 to 9, in which case you round up. In this case, we're always rounding up to the next whole number, because this, what we're looking at right here, is the minimum. So we can't go lower than this. It has to be this or higher. And the smallest amount from here that we could go higher, where we hit a whole number, is 224. So the answer here is going to be 224. So now they're giving us a second part. Now they're saying, assume that a prior survey suggests that about 35% of air passengers prefer an aisle seat. So that prior survey gives us a p hat now. That gives us an estimate of what the value is going to be. So let's go back to Excel. So now in this new survey, we're going to have all these same things here. This is all the same. But in addition, we're going to have a p hat. So p hat, or if you prefer, you can type it p hat like this. So the p hat, they told us, is 35%. Again, we're working in decimals, so it's going to be 0.35. You can do that by doing, if you like, an equals 35% divided by 100. Or you can just move the decimal 2 places. So now we know the p hat. So now if we go do the minimum sample size under these new conditions, this is going to be the formula following along with this guy right here. So we start with an equal sign. First we need the critical value squared. So we take the critical value and square it, caret 2. Then we're going to multiply that by p hat, which was this. Then we're going to multiply that by q hat. Remember, q hat is just 1 minus p hat. So we start parentheses and do 1 minus p hat. Close the parentheses. And we divide all of that by the margin of error squared. So divided by the margin of error, click on right there, squared, caret squared. Hit enter. So in this case, we get 203.4748. Again, we're always rounding up to the next whole number. So the next whole number up from there would be 204. So here we would have 204. So the point here again is, if we're trying to get results from a survey that are as good as explained in the question, if we didn't know anything about this population from a prior survey, we would need to sample at least 224 people. If we had information from a prior survey that told us that at that time about 35% of air passengers responded in a certain way, then in that case we'd only need to survey 204 people.